Good morning to all assessors. We'll be presenting the whole process of our project. As we have mentioned in our presentation, ABR has a very small signal, hence it is vulnerable to any noise and artifact. In order to minimize all possible interference, we chose to conduct the test in the X-ray lab. It is the most shielded place in RP. Now, we will move on to the room where we will conduct the test. First of all, we will need to include more shielding for our signal conditioning circuit and our DAQ. At the same time, we need to make sure that there is no AC power source being used, no handphone reception, no wireless connection, and no light source to further minimize the noise from the environment, due to the fact that AC power source is the major contribution to the artifact. Secondly, we will need to clean the patient's scalp as well as the earlobe. The purpose is to remove any dirt or dead skin that may cause loose contact between the electrode and the skin. Next, we will place 3 electrodes on the patient. The ground electrode on the lower forehead, inverting electrode on the upper forehead, and lastly, the non-inverting electrode at the earlobe of the site that we are testing. After which, the light will be turned off and ensure that the patient is in a relaxed state. If possible, it is advisable for the patient to be asleep. This will help to reduce any possible human artifacts from the patient. For the test, we will need to take at least 2,000 samples and average the samples at the end to get the ABR waveform. The whole process will take around 10 to 15 minutes to complete. To show that we have successfully obtained the ABR wave, we did multiple times of the test with the patient with normal and abnormal hearing ability. So from the result, we can see that when the patient can hear the stimulus, it clearly shows a wave 5 of the ABR wave. Whereas, from the wave obtained from the patient with abnormal hearing ability, it clearly proves that there is an absence of wave 5 and ABR wave.